Hi, welcome to the video. Let us see in this current mirror circuits. So how do we find out the current that is mirrored in different combination of N and PMOS? We are asked to find what is I copy here with a current, with a reference current of 1 milliampere from here. The W by L ratio of different transistors are given here. If we want to find the current that is flowing, that is in this arm of the circuit, I2 is given by, it is I reference, that is the current that is flowing here, multiplied by the W by L of second transistor by W by L of first transistor. So if you can see, this is I reference is 1 milliampere, that is this current, and W by L of this is 2 times W by L of N. How about this? This is actually 3 times W by L of N. So this W by L will go off. So now I2 is actually equal to 2 by 3 milliamperes. This is the current that is flowing in this. So now this current is again mirrored using this M3 and M4. So then what is I copy? Of course, one assumption that we are making in all mirror circuits is all the MOSFETs are in saturation region. So what is I copy now? I copy is now I reference multiplied by the dimension of this transistor, which is W by L of 4 by W by L of 3, that is this transistor. So for this becomes the reference transistor and this becomes the current I2. What is I reference now? Of course, let me write as I reference, I dash reference. So what is I dash reference? It is actually I2. So is it not 2 by 3? What is W by L of 4? It's actually this, that is 3 W by L of P. And what is W by L of 3? W by L of 3 is 5 into W by L of P. Sorry. So this is my I copy. The current that is flowing here is nothing but, so I2 becomes the reference current then. So I2 is my reference current, which is 2 by 3, and dimension of this is W by L of 4. This is 4th transistor, this is 3rd transistor. It's W by L of 4 by W by L of 3. W by L of 4 is actually 3 times W by L of P, and W by L of 3 is 5 times so and so. So then this will go with this. So what do we have? It is 2 by 3 into 3 by 5. This will go, it is now 2 by 5 ampere. 2 by 5 milliampere. This is milliampere. So it is now it is 0.4 milliampere. So it is 0.4 milliampere is I copy. So it is, so current that is flowing in I copy is 0.4 milliampere. So let us see what is this current. So what is I copy 1? If you see I copy 1, if this is 2 milliampere, is I copy 1 is equal to 2 milliampere multiplied by 5 W by L of N by W by L of N. So does this go? Is it not 10 milliampere? Is this not I copy 1 is equal to 10 milliampere? So this is 10 milliampere. If this is 10 milliampere, taking this as the reference, what is I copy 2? I copy 2 is 10 milliampere multiplied by W by L of this is 2 W by L of P by W by L of P. So this will go, will it not be 20 milliampere? So this is 20 milliampere. How about this? What is I copy 4? I copy 4 is the reference for I copy 4 is this, which is 2 milliampere multiplied by this is 3 W by L of N divided by W by L of N, which is now 6 milliampere. Correct? This will go with this, so it is now 2, this is 6. So here I have 6 milliampere. So this current is now 6 milliampere, this is 10. What is I copy 3? I copy 3 is nothing but I copy 2 minus I copy 4 is actually 20 milliampere minus 6 milliampere, which is now 14 milliamperes. This is my I copy 3, because this 2 milliampere when it is mirrored here, because the ratio of this is 3 by 1, it is 3 by 1 into 2 is 6 milliampere is flowing here. How much is the current that is flowing here? For this 10 milliampere become the reference current, so it is 10 into 2 by 1, so it is 10 into 2 is 20 milliampere. Here it is 20, here it is 6. The rest that will go here is, if you write a KCL here, if you write a KCL at node A, so it is I copy 2 is entering is equal to living current is I copy 3 and I copy 4. So this is I copy 3, I copy 4. So I copy 3 is nothing but I copy 2 minus I copy 1, I copy 4, which is 20 minus 6, which is 14 milliampere. This is 14 milliampere. Okay. So what else? Okay, let us try to find out some of these things. So we have been given some parameters. We are asked to find what is R1, R2, RD, and we are also asked to find the bandwidth. CGSO, CGDO given is in terms of farads, so no need to multiply that with width, and width dimension is also not given, so it's fine. So CGSO, CGDO are directly given. So now let us find out R1, R2, and so on. So AB is given as -4. We know that the expression for AB is minus GM into RD. So we don't know what is GM, we don't know RD also, because RD is also not given. RD we are supposed to find. GM also not directly given, but of course some of these parameters are given. So let us find out how to do. So what is VOV? VOV is given as 0.2 volt. Okay, fine. And okay, what else is given? That's it. So since VOV is given, can we find what is VGS is? VGS is equal to VOV plus VTH, which is 0.6 volt. VGS is known. Since you know VGS, you know what is KP. Well, can I find ID? ID can be found, which is assuming the MOSFET is in saturation, because naturally if the gain is there means it's in saturation. ID sat is nothing but half KP W by L VOV whole square, because VGS minus VTH whole square. So this comes out to be 100 exponential minus 6 into W by L is 25 into 0.2 whole square. 0.2 whole square. So current is 100 max ampere. This is my ID. So once you know ID, I can find GM. So what is GM? So GM is 2ID by VOV. 2ID by VOV, which is nothing but 200 microampere by 0.2 volt, which is now 200 exponential minus 6 by 0.2. So it is now 1 millisiemens. So I can use this GM here and find out what is RD. It is -4 is equal to -1 multiplied by RD. So now therefore RD has to be 4 kilo ohm, correct? So this minus minus will go, 4 by 1 milli is 4 k. So RD is 4 k. So RD is 4 kilo ohm. So this RD is 4 kilo ohm. Can I find what is now, since now I want to find R1 R2. So what is actually the voltage at this point? The voltage at this point, if I say it as VG, VG is nothing but, let me write, VG is nothing but VGS plus ID into RS, because whatever is this voltage, VGS plus ID into RS is your VG. This is equal to VDD R2 by R1 plus R2, R1 plus R2. So what is VGS? VGS we know it as 0.6. What is ID? It is 100 micro. What is RS? It is 100 ohm. So this becomes 0.6 plus 100 exponential minus 6 into 100. It's actually 0.61 volt is VG. This is actually VG. VG is 0.61 volt, which is equal to VDD R2 by R1 plus R2. So we know 0.61 is equal to 1.8 R2 by R1 plus R2. So now we have to find R1 R2, but both are unknown. But one hint is given. I cannot assume whatever value of R1 as some value or R2 as some value. Since I want to get R input impedance for more than 50 kilo ohm, so I know that R input impedance is nothing but R1 R2 by R1 plus R2, and the voltage that I am getting here is 0.61, which is less than half of this. So VG is less than half of VDD, therefore R2 has to be less than R1. Why this has to be, R2 has to be less than R1? Because if the voltage at this point, which is a potential divider, if it is less than 0.9, so then actually R2 is less than R1. So how much the voltage that you have here? You should get 0.61, which is less than 0.9, that is half of VDD. So R2 is naturally less than R1. So whenever R2 is less than R1, in a parallel combination, the lower resistance always dominates the Rn. In suppose if you have two resistors, R1, R2 as your Rin, so what is Rin dominated by? Rin is dominated by a lower resistance. So let us assume that since I want to have Rin to be greater than 50 kilo ohm, let us assume the least of these two, the lower value of these two, as twice of that. So therefore R2 is taken as 2 times the minimum, that is 50 kilo ohm. So let us assume R2 as 100 kilo ohm. So now use this value of R2 as 100 kilo ohm here and then find out what is R1. Is it not 0.61 is equal to 1.8 into 100k by R1 plus 100k? So you can find out what is that. So I'll do that. 0.61 alpha equals 1.8 into 100 divided by 100 plus alpha a. Close the parenthesis, shift can. So this is now 195 kilo ohm. What is this? This is actually R1 is equal to 115 kilo ohm. You can just substitute and then find out. So let us use this equation. So what is VG? It is 1.8 into 100k divided by 295k. So how much is this? So just for cross verification, 1.8 into 100 divided by 295. Can you see it is 0.61 volt? This is what is expected. So the value of R1 is 195k, value of R2 is 100k. So let me just again redo it. we started with the value of finding the value of RD. To find the value of RD, since GM is also unknown, so we actually found the value of GM first, so for which I need to know the value of ID. So ID we can find out because we have been given what is the overdrive voltage. It is coming out to be 100 microampere. Substituting those, you get the value of GM. So once GM is known, you can estimate what is RD for a given gain of 4. So next is to find the value of R1, R2. So I know what is the voltage that is required here, VG, which is nothing but VGS plus ID into RS, because the current that is flowing is ID here. This is ID into RS, so that's what is this, which comes out to be 0.61 volt. That's what is this. You can see it is 100 exponential minus 6 into 100. It is actually 0.01 plus 0.6 is 0.61. This voltage is derived from this VDD, which is nothing but VDD into R2 by R plus R2. Since it is lesser than half of VDD, R2 is actually less than R1. So this is an important thing. So when you have two resistors in parallel, the least resistance always dominates. So let that least resistance itself be greater than this. So naturally your input impedance can never be less than 50k now. Suppose if you want to find what is R in, you can surprisingly see this will be more than 50k. So how much is this 100k in parallel with 195k? It's very easy. 100 inverse plus 195 inverse equals inverse of that is actually 66.1 kilo ohm, which is more than 50k. If you get anything more than 50k, it is fine, because you have to get greater than 50k. So we are done with this, and we are asked to find what is the bandwidth. What is the bandwidth of this transistor? To know the bandwidth, we know that okay, this is what we did. This is what we are supposed to. Let me again redo it. This is frequency. This is AV in dBs. Let us write it like this. This is now flat, comes down, and then you can see there is one more change in slope. This is one frequency, come down by 3 dB. This is one cutoff frequency. This is the cutoff frequency. Bring it down, bring it down. This is F1, F2. Write it as 3 dB or minus 3 dB. This is AV max. This is AV max magnitude. And then this is so and so. Okay, this is, let me write as F3. This is frequency in hertz. Frequency in hertz. What is F1? It is 1 over 2 pi Cc R in. F2, 1 over 2 pi R out C out. R out C out. What is F3? 1 over 2 pi R signal in Cn. If you can see here, since R signal is not at all given, R signal is not at all there for this, R signal is not at all there, so then this is not coming to picture. So this is not coming to picture at all, so you don't have any change in slope, it just goes like this. So you need to find only these two. So what is F1 now? F1 is, so you can find out 1 over 2 pi 0.1 micro ECC, and this was 66 kilo ohm, because this is 0.1 micro, no? This is 0.1 micro. We have 0.1 micro, input impedance is 66 kilo ohm, this is 66 kilo ohm. So then this is, let me find it, it is 2 into pi into 0.1 exponential minus 6 into 66 exponential 3 equals 1 over that. It is 24.1 hertz. This is hertz, you can see 21 hertz. What is F2? So actually 1 over, we need to actually find out C out. So what is C out here, friend? C out is CGD into 1 plus 1 over AV. 1 plus 1 over AV magnitude. So what is actually AV? We found, of course, AV given is 4. Is it not? How much is CGD given in farads? It is given is 40 picofarad. It is 40 picofarad into 1 plus 1 by 4. It is 1.25, that is 50 picofarad. 50 picofarad. So let me find out this. It is 2 pi 4K because R out is RD. This RD is found out to be 4K now. And this is 4K and this is 50 picofarad because this is 1.25 plus 40 pico is 50 pico. It is 50 picofarad. How much is that? 2 into 5 into 4 exponential 3 into 50 exponential minus 12. Okay, 1 over this is, okay, it is 795.7 kilohertz. This is 24 hertz, whereas this is 795 kilohertz. And of course we don't have any F3. We don't have any F3 because there is no R signal. So you will have only two cutoff frequencies if there is no signal source resistance given. So you have only two cutoff frequencies. Let me rewrite it again. You have only two. This goes like this. Right. Okay, this goes like this. Then this is this. Then it comes down. So you just come down by 3 dB. This is 3 dB. F1, F2. So you have maximum gain. Of course you can specify in terms of dB also, which is 20 log 4. How much is 20 log of 4? It is 12 dBs. It is 12 dB is the gain. This is AV magnitude in dBs. So this is 24 hertz. This is 795 kilohertz. So this is, of course naturally this will be, okay, what is 12? This will be 9 dB. No need to mention that. This is how it goes. This way you can able to comfortably do the things. Thank you.